Okay, recording. All right, so now you should see the full screen. Okay, let's do this again. All right, uh, did someone just ping me? Is there something wrong? Okay, so okay. Mm. All right, so unless something wrong, don't ping me. Otherwise, I have to get out of this mode. Okay. All right, so unit reviews. Okay, so this unit is being a content, so you will familiar with the contents of the lecture. So that should be highlighted on the Milo also very clearly. So I upload the slide from today into the to Milo and tutorials. Okay, on the right hand side. Okay, so these there are different components of the lecture components. So the virtual interface. Okay, so the human computer design process. Okay, and the VR and then 3D interactions. And then we also talk about how to evaluate them in usability. Okay. We also talk about how people collaborate and using them for altering tools, which is seem to be the application that most a lot of people can attracted to. So that's what can sort of look like a work in progress. Okay. And we also are looking at the different configurations of the interface. Okay, the tangible TUI, tangible user interface, is one of the difficult one, the one of interesting one, I should say, and also spatial AR, which is a really nice setting. Okay, so a really nice, complicated, but it's very, very interesting one. Okay, and machine size of interface. Okay, so that's one of the things that you can take a look what behind the scenes. So since it's not really applicable to our unit per se, as it's driven by a lot of technical components, not just software, but it's all software, I mean algorithms, but it's also on the hardware side, it's electronics and sensor, things like that. So we only can see and look at them. Okay. And for the tutorial and also from the practical point, we run a couple of sessions. So you will see that we are play fully in tutorial. Ron done a very good job in the Unity 3D. And then, all right, so the audio has some problem for maybe for Ruben then. All right, so maybe Ruben, so you probably need to check out your audio. Doesn't look like. Oh, okay, it's fixed now. All right, let me go back to my slide again. Okay, so where were we? Okay, so VR software in our software. So that one is, as you know, Ron is running heavily Unity focus, running off the Unity component completely. So that means you will get a chance to look at them. Unfortunately, we don't have a chance to, or at least not everyone have a chance to deploy to the headset. So that's unfortunate, but you can get a sense of that. If you come to the practical, you can kind of see that it's not too far from the content that you have to go to the headset. And then 3D model asset. Okay, so that one, it's not the focus of the unit, but we just need something there. So hopefully you get the chance to play around with somebody else content, import them, get them in and play with them. So hopefully that will be a good useful exercise for you. And now you in the last stage, since last week in the tutorial, really focus on you how to get people to test them. So you're gonna get them do this week. Okay. Some of you will test among your group, between different groups, and some will go test with people outside the group, like you go to more your friends and your colleagues. Okay. But this one is not just how get the people play it. So last week, Ron would have run a session that how to guide you to design it. Okay, design testing questions. Think about what to test. As I think the bulk of the testing here is really, it's not just have an application idea and you know what to test. You have to know what the focus of the testing are. Okay, that's what I exercised last week, so to get you help thinking about rather than just focus on to show you show you a tester just your application, because the application you develop are far from finished. Okay, it's just a beginning of what your idea might look like. Okay, so that means that you have to be very clever on how you test them. Okay. Otherwise, your data will come out less meaningful than it should have been. All right, so this is a kind of general context. Okay, so the practical sessions are taken by the, probably around the first one that I run in weeks 5, I believe, is about 1/3 of people show up. Okay, and then the second one is half of that. So it's not a very good turnout. Okay, but for those who turn out, it's actually should get a very good experience hands-on. So we'll see what happens next year. Hopefully, we'll be able to get back to that a little bit more. Right. So this one's virtual interface. This is covered very early on in the semester. Okay. So this is a virtual interface. Okay. So this is a just guide you what is the components of what interface. This is a statement from what we stated up before. It look legitimately statement look a bit kind of statement. Okay, look like oh yeah I think I kind of understand and shoot it. Okay, but now having you done all the design process, you would know that step one are really pretty much focus on this. Okay, really trying to define is what's the problem, why with interface you need to build it. Okay, I think that's a lot of assignment too that I've seen. I really not understand this part. Okay? You tend to just show off what you have. Okay, this is not assignment to show off, and this is assignments about how to help design. So that means as a simple thing could be very good design work. Yeah, not necessarily the complex thing. Okay, but it definitely not something that you all you know is what you want to talk. So this is kind of give you an idea. Maybe you can start with, oh, maybe the work is complexity, and there was some issue with that particular domain that you pick, okay, like a phobia, for example. Why was it important to have them test in VR, not just to put them in VR for the sake of assignments? You need to identify why you need to do that. So hopefully this will give you the idea on that. Then kind of moving on into the matching between human and machine. So this one is looking specifically on 3D components, okay, spatial beings, and how we build mental models. So I think some of you touched on this on the really good assignment I saw. Okay, I commented on that, which is some of this is good. So that means you start to detect things that okay, this is interface not just a box. It is something that human design for humans, not human design for machine. Okay, so therefore you need to recognize not what you build, but what you build, who you build it for. Okay, so this is identify under foundation fundamental problem that we have. We still have problem at the moment. Okay. So therefore, this lead to one of the major concept, the first early concept that we're looking at, the virtual interface, to map between the sensory of the humans and the data itself that you're presenting. So there are very, very different way of looking at them. So the data, you need to look at what type of data, how do you organize the data, what sort of problem of human having looking at that data. And then now you're looking at how humans perceive, what the mental models look like, perception level, the time, the cognitive. So there are many kinds. So it's not going into that detail, but you should have a kind of overall sense of understanding. So that's become our term of what we call virtual interface. So this is our diagram that we use heavily. Okay, so that is the duality of virtual interface. Okay, so this is on the right hand side, the experience side. Okay, experience here, how people are using it, how would they feel, how would they perceive that content. So this is a kind of human size thing. Technology side is simply what they are. This is just a click button, doing date checking hand things. It's very, very kind of task oriented. Okay, so but you need to somehow build this together. Okay, that become the what the virtual interface are. So I'm kind of put them together in the last few slides. So you hopefully you get the idea here. It's not something that I mean you can describe them in this sense as well. Okay, so in this case here you can see the diagram here is a human and the world. You see the technology side on one hand and the experience side on the other hand. Okay, so experience sides are more attached to human because human is a user in this case. And you have technology side, which is dealing with some of the sensor, dealing with insights, and then how to generate what it's supposed to do. Okay, so that is a really quite a fundamental concept in our unit. Okay, so hopefully that give you a sense of what that might be starting off with your unit. Okay, with this unit. And then we go straight in lecture 3, we go straight into this, which is a concept of the same thing here, but how to actually make this. And now we recognize there was experience side, the technology side, there was component, different aspect of we are looking at the same core. But how do we design the interface for this? So that's what the human computer interface is, to make that purple link both way, trying to understand the technology at the same time as the experience of what should be as humans interact. Okay. And so that's what we design for, and that's the step that we've been following. Okay, so I'll start with identify the user requirement. Usually, the step one is people are quite misunderstood what it means. Okay, so step one is not just what a user need to do. Some student describe this as how many features they have, how many things they have to do, how many they have to walk to this door to open the light and things like that. That's not the case. Identify user requirements here as a user needs. It's more linked to the problem that we have before, like what are the shortcomings of what current interface will look like, what are the problems, which I linked to you a couple of slides before, which is I think some of these is more kind of components of that. And this is the foundation of some of the problem you might have. Okay? Like a phobia, for example. The situation here is it's critical, it's very time consuming and resource consuming to be able to do the actual testing with the spider, and also you can control the level of exposure and like the simulated environment. So those are sort of things you have to describe. Okay, that's where your interface can be built on. Okay. So okay, going back there. So that's the first step. Oftentimes you didn't quite get it right. So hopefully my correction in your assignment 2 will lead to a better in assignment 3 and 4. Okay. And the interface requirement number 2, oftentimes people kind of skip them because assignments 2 or 3 ask you to do VR, AR. So you just simply describe the technology that you use. Of course, in this case, in the design step here, you do need to, step 2, oftentimes it could look like an obvious thing, but it allows you to think before you have to pinpoint the technology. Okay, if you're not super clear to this, go back to my slide lecture. So this second thing is really about how to design. You know the problem that the interface should make an impact in step 1. You identify the scope of the problem. The step 2, you identify what sort of a requirement that will require from interface to do. Like the interface need to be able to interact, need to be able to project immersive environments, those sort of things. So you don't need in this step 2 here strictly. You should not fixate on the technology, because it could be a combination of technology. Our unit deliver them in AR, VR, but it doesn't mean that it can may not be combined. It doesn't mean that VR cannot be combined with a tangible user interface like a spider project, for example. So you can put a VR, but you can have an object that look like a spider in a physical world that has a tangible sensor on them. Some of those. So those are where usually the step 2 miss or omit, what you most likely will end up with a very narrow interface solution in number 3, because you already fixate number 3, what is I'm going to use the VR. Okay, when in fact VR might not be the best solution. Okay. Um, Step 4 here is really encompass deep dive into the thinking of the design, into interaction designer, like this unit is try to focus you. It's not just about drawing a storyboard. Okay, so it's not just about that. It's just about getting the design. Design means and how we will get interaction. Okay, how will you get interaction with them? I should just go for this slide a little bit. So in this case, it's a compelling user experience here. So you start with the bottom, which is the foundation components, all the hardware and things that make it work, which is essentially the technology side. And you have the tool that allow the user to put in contents, build things like that, what you're using mostly in that layer. And then now with all the tools you have to design with application. That's what assignment in this unit is for kind of give you the experience and channel you to building certain type of application. And in application here, if I go back to this one, step 4 here, it really, you bring up your interaction. So you describe different interaction part, okay, that might be that were helpful. As the lecture projected, storyboard is not just about getting the fancy drawing out. In fact, it's not really focus on this, but really get your idea of how your application can be interacted by the target user, target audience. Um, for, Basically keep the idea out so that you can brainstorm within your team. So hopefully the assignment 4 coming through will have a little bit more rich discussion around that topics. Okay. And then of course step 5 is that what you been spend a lot of time on in the tutorials and your own times building a proof of concept application. Okay. And then now this is a usability in the step 6. So that just to get the idea of what people think, what your target people think, what they'll design for. As I said before earlier, is that it's not necessarily at this stage to focus on all aspects of your work. By design your question to be very generic. Do you like my application? Do you think my application would do certain thing? I mean, those are kind of very old top, very kind of high level top questions, which is of course you will get the answer something if you get a subject to test on, but the data may not be anything much at all. Okay, so therefore in step 6, oftentimes people will focus on certain area that is considered key component of their proof of concept. Okay, for example, you build a spider phobia application, you should ask some of the things like, oh, if your application really try to provoke that step, you should really ask about how the spider look, how realistic it look between 1 to 5, things like that. So you should be kind of try to focus instead of you try to whether this will kill the phobia. Okay, because that's a kind of nice looking app, kind of a question to ask, but it's almost impossible to get the answer, a meaningful answer, because it's too broad, too high level, and compared to what you have. So those, for those kind of question, top level, you do need to build up your small testing. In this case, to leading up to that, that you know for sure this characteristic of these spiders provoke certain level of realism for the user. So then you can kind of build further from there for build a project, longer try, retentions, whether how they feel, how their rating feel, maybe every 2 months, would they feel about that. So you kind of start to look at the deeper cognitive sides of the testing, which is that's when you kind of toward the end of few years of trials and you start to ask the top level question like that, but not definitely not the beginning. And of course, the step 7 here, which is part of your assignment 4 as well, which is to modify the initial design. For assignment, this one was designed so to correct the directions. So you hopefully you do this kind of agile development part. So you do some bit that you think is the most innovative part or cool part of your design, and then you build prototype for it, and you test specifically for that. And then you try to fix until the core part is finished, until before you expand to the whole picture, your whole application design scope. Okay. But in your assignment 4, this part was relatively just writing corrections, unless you have something, unless your application didn't work in step 6. So of course you probably want to get it working. Okay. And at step 7 here, you do need to modify addressing it. Okay, to addressing, okay, this is how we plan to do this. We plan to do that, or people suggesting it's not clear here. So what your plans look like. So that your group should have a think about that how to resolve. It shouldn't take super long, maybe a couple hours to think about looking at the outcome. That's why step 7 may not be much at all. If step 6 you ask the wrong questions. Okay, if you ask a very generic question, you most likely won't have much to say in 7. Okay. So that hopefully this is design the whole process here, give you the idea. Okay, so the idea and guidelines how to design in the future after this unit. Okay. So again, so the top one here is the one that everyone try to get to. If you've been around on the social media, you will see a lot of AI start to make a push. Okay, so AI application or the social media video, TikTok and Snapchat have been playing around with this AI. So what they try to get to is not interaction, not what they can. I mean, those they have a lot of resources to make that happen. What they're aiming for is a top level, which is now can everyone use it? Can everyone hook to that? Those is still jury is still out, so we don't know whether those kind of snappy applications are really working. Okay, so but hopefully that give you a sense of appreciation of how build from step there. Okay, so maybe some of you will join that team in the future. All right, so the next one, so we go straight. So this one, I don't need to talk much because I think you're familiar very well with this. So we'll have these different parts. So we have AR in the bottom right, and we have VR in the top right, and AR in the bottom right here. So just to give you a sense of diagram to retouch on it. So this one has a virtual environment, so we are completely immersive. Everything's embedded inside your headset, so you're completely cut off from outside. But the way to represent the VR is not you cut off. It basically you'll be able to control the environment that user perceive. Okay. Of course, even though it's just a visual, audio, but in the in the future, this could be like Star Trek, holographics, simulations, things like that. So who knows? So this is kind of technology, but the idea and design is really the same thing. Is that you take people out of their environments and put them in a completely new environments. Okay. It depends on how and when the technology in different area, maybe the smell, aroma, olfactory style sensors start to come up, and then you start to feel, you start to really know your terrain, be able to change the temperature to change. So those are, I think, simulation like this is a lead a lot in military space. Okay, for that we also participate in a simulation in a very harsh environments. So that those are kind of things that are coming online. So you will start to see them in the next 5, 10 years. Okay, but just so you understand the concept. Okay. So this is just a headset we play with today. So technology is changing relatively quickly. So so this is some of the application there. So the payment, there all kind of things. So hopefully you not just think VR is for game. So for other things that kind of could have impact to the real world. So for AR here, so this is a concept that developed a bit later. The same group of researcher. Okay, so in this case, there are two different modes. All right, so this is augmentation. How would you augment it? So this one is called optical see-through. So this one, the real worlds, is merged with virtual worlds in electro-optical combiner. So essentially, it's just a piece of glass that you combine two different things. So you allow people to be able to see the virtual component, which is in red arrows there, to be kind of combined to where you are in space. However, ability for you to track yourself in space is very important, just like VR. But this one is important, otherwise the augmentation will be in a wrong location as your head is moving around. So that is again military reading that space, but it started coming with a HoloLens. In the practical session, we run a HoloLens tool, so you get the chance to kind of play with what currently considered state of the art. Okay. Military get those HoloLens to modify, work with Microsoft, modify it to be a headset for their future military ground. And the other one is more practical, but this is before this one no longer be the headset that people build. People now just go straight for the headset to go to optical see-through like HoloLens. This one is really more on the using video graphics and a camera as primarily as a way in which you observe the real world. So this is more nowadays more not headset as I said before. This is more or less like mobile phone, okay, mobile phone, Vuforia, webcam, those sort of things. So people are now more into that. Start to have a distinctive between them, between optical see-through, which is currently technology is a more head with head head mount display oriented, and for the video see-through are more camera and mobile phone oriented. Okay. So and then in lecture 6 we talk about 3D interaction. Okay, so this one is actually the concept here was the design. Okay, the design of interaction. We talk about that in storyboarding. We should have a design in place. So this one is just highlight that the design now, the concept, proof of concept now, further you're more mature, you step from the step one, proof of concept, you're kind of going down there and then start to adopting other people, interaction that you know in similar field. And then when you get more mature in a few years to that, and assuming the interests do there, okay, because some technology, they might not survive. Like they may just be there and then they kind of disappear before people adopt them. Let's assume you have, then the next step you start to develop your new interface that more suitable to what you actually need. Okay, to your, the medium, either VR or those other things need. And then in the end, you start to be developing a more formal theoretical models of that, which is you can use that prediction, human perception, and a lot of those fields. So right now in computer interface, is the only one that make it to the step 4, the most mature, is a desktop. Okay, people can predict how the screen side, the cursor, the icon side detected, what the task efficiency can be calculated in mathematical form. Other people like VR been around for many years. It's still in the phase that they have the tools specifically for them. Teleporting, which should really come from VR, are really one of the good example of new interface metaphor that designed specifically for the medium, so that the side of the VR is more much getting to the mature state. Okay, and then AR, which is adoptions, which is right now is still adopting a lot of these, but they moving toward number 3 now in Gartner hype cycle. So AI now come off the technology hype list. Okay, so that means that it's no longer seen as a new future technology. It's being seen more as a technology that now is everyday thing. Okay, and the company Snapchat just released software, but it's only available in the mainlands. Okay, so this is about using your mobile phone to paint the real world, but they have to the technique they use for that is quite interesting. So I'll show you quickly on that one just for the kick. Okay, hopefully you get the idea. Okay. So the user interface in VR, this is more very established, as I said before, object interaction, selection, navigation, wayfinding. So they're all sort of, we sort of familiar with them. And Ron runs some of these in the tutorial, so you should be able to have some of these experience already. AI is a bit kind of mixed. Okay, so you mostly still use touchscreen, data annotation, 3D. What you use mostly is data annotation with the marker, image target of Vuforia, and you have virtual object come up, and then you have virtual button, things like that. So that's a sort of an interaction the AI people commonly use. So the usability testing, okay, so this is one we talked about that before. The first thing is that when you design the problem, okay, it's one these things need to come up. It's a target audience. You need to know who you designed it for. Okay, it's not the same thing as I keep saying. It's not about the same thing. It's that you showcase what you do. You basically try to get people who you designed it for to use the way you designed them to use. Okay, so that's quite complex stuff, aspects that you're trying to get it right there. Okay, so that means that you have to pay attention to that. So the evaluation paradigms, there's a quickly the different areas, a quick and dirty, which is really just what you're doing here in the tutorial. When you build a quick prototype, you get people to do a quick test to get you an idea of is a spider scary or not scary, or they really create this and that, things like that. So to get the idea for you to kind of get your core components right. Oh, sorry. And then usability testing in the lab study. Okay, so this is where you move up a little bit. Field study is when you actually throw into the space, get the real object, you use it in the real patients, and in the clinical trial and things like that. So that's quite complex. Okay, and then the last one is only when the technologies are there for evaluation for using mathematical formulas that you can actually form them. So that's you need a lot of data to be able to form that part. So usability test process. So you have a different way. This one I put out the guidelines. Okay, design, detail, usability. So that you have to decide what the design first for the beginning. What's the purpose? Remember, this is a step 5 in your design process. So you already know a lot of this. This is really just a touch base. So you don't end up just testing something, as I said before, either too generic or too broad that is not linked to the real application or the one that you're presenting them anyway. Okay, and then you're gonna come up with a design of okay, what's are the tasks, because you use a task as a way to carry or to test what you have. For example, if you ask about spider, realistic spider, you're not necessarily just asking about that. You ask them to do a task. For example, oh, why don't you go grab an object that happened to be sit behind the spider, and when you move to it, spider reacted, and then you ask about it. So therefore, you use a task as a way to care a mean to an end to get them to get the experience of it. For example, if you design environmental in VR that reflective light that can be creating in realistic environments or dawn and dusk for the environment. So I just make this up, but so what you will design to do is that you will decide to know, okay, it's an application. If you sit here, simulated the time. So what you find out how the time is working, whether the light switch is working, things like that. So you sort of not go, oh, it's a light switch working, and you design the task so they click the switch, which is really straightforward. So instead, you actually design them something else to do, or in order to do the task, they have to engage with all this feature that you build or target feature that you want to test. So that's the way it's the task to be designed. Okay. So you can go back and look at my example of our current project with the forestry. So that one is also have the task specifically designed. Okay. And then also you're going to determine the method. Okay, so that going to do the data collection. So in this case, we touch on really quickly. It depends on the type of task you have. You might actually look at the task accuracy, completion times, if disability test, if they are looking at experience, so you might be looking at how enjoyment, what their rating, subjective rating of their enjoyments of the environments, things like that. It depends on what you're looking at. And recruited participant, this is linked to the target audience, even though I don't think we have to do that in actual assignment 4, okay, because if you design for phobia, then I think you have to get the people who has some phobia component, known phobia clinical components to play with it. Okay, so in this case, you really try to get the right people who the fit profile of your target audience to test you. Yeah, but don't worry about assignment 4. Assignment 4, Ron should have advised you that you use a scenario. So that means that people will just pretend that, let's say they have a phobia. They just pretend they have a phobia. Okay, so that's them or the subject that testing it, and then we'll go carry it from there. Even though it's not ideal, but at least it's at least you tell them something. Okay, so and then you run the testing. So typically testing are run controlled by people who develop the application. So you oversee all the steps. So there's no anything shouldn't be done during the session. But again, in assignment 4, it's probably not possible unless you actually run in person to your friend. Okay. And then report the findings. So that number 4 and number 5 are different. Oftentimes, if you haven't written any research report or kind of analytical paper before, there's two different things. So first, you should just purely report the result. Okay, what they are, standard deviation means, and that's not analysis. Analysis is really trying to find what the finding really mean in the context of your study. Okay, so in that case, you might be looking at why would this one is more why would the average value of how people like certain feature of your app is low? What does that really mean? So you won't have the complete answer, but you need to try to aim for that. But you definitely got to aim for that. So therefore, you try to frame your analysis around those contexts. Okay. And remember that analysis here only makes sense if you have relatively large volume of data, like 10, 15, 20 subject to play with. Um, but in your assignment 4, again, your analysis don't overclaim too much. Okay, that they all like it. I mean, that's state in the report, but analysis you should say, this indicates a positive indication. However, pending that the subject is number of subject is low, so therefore this is only indicative. So that's a safe way to go with assignment 4. But in typical usability testing, that's you have to calculate statistically the power of the statistic that that you find from the data set, which another topics of the subjective or qualitative study. All right, so then we are looking at a collaboration and authoring. Okay, so one is kind of looking, give you a sense of two different things between cognitive theme and functional themes. The task, the type of tasks are changing, or the type of face-to-face. I mean, we all affect a lot of this now before. Now with the cognitive theme is now really, it's a tutorial selling the difference if you run in the sessions in the tutorial lab versus what we have been doing in here with Ron. And in the same thing with lecture. clearly notice a bit of a disconnect. Okay, like I'm now talking to the screen, not talking, seeing student in the face or face of students and eyesight and attention. So that's affect my teaching feedback quite heavily. I'm sure you probably have similar thing from your end. Okay. So, but anyhow, those would be the kind of issues of what collaboration, how does that affect. So in this unit, you just recognize some of the major component, foundation, fundamental elements that could affect them. That would be good enough. For the altering here, in the concept of AR, VR, the focus of this unit, this is a part that you kind of need to kind of take it. So therefore, the desktop is at very bottom end. The data volatile, it could be any form. You can play with them. And then VR, to put the data in VR, you're not going to put Microsoft Word data textual base inside VR. Okay, so it got to be 3D spatial data. So that could be a point cloud in one of my project in VR in the form forestry, to scan the forest, or you can be a spatial data mapping, constellation star, or those sort of things that has a spatial space X, Y, Z in space. Okay, so but then that's what we call specialized. Okay, specialized moving up this, so the data need to have specialized to be in the VR, best use of VR technology. And AR take that further step. Not only specialize, it need to have contextualized to get to the AR. So that means that you're not going to put a simulation data that you run in VR in AR particularly, because AR would the best use of AI technology is need to have contextualized. Contextualized means it has to be context in how you display them. For example, augmentation. The Google Map now start rolling out the 3D AR version. So that means that you can just hold up your phone and the arrow will come based on the way you point your phone. So instead of you just looking at 2D map of the Google Map on your two screens, so now you're just looking at the screen, but you just point out in the real world and you see the arrow, 3D arrows there. Contextualize in that sense is that contextualize with the real world environment, which is the key part. It depends on what that means. So in military simulation, AR would need to be able to augment information that actually exists in that 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 relevant to the real world, like the enemy coming from this back of this hill, something like that. So you need to be able to put the spatial data contextualized into that space. So that's the kind of if you can get this concept, I think you understand the foundation, the key foundation that I want to deliver in this part. So for this one, the tangible user interface and spatial AR. Okay, so this one, as I say, is a different, unique form factor, different than what typical we do with the visual stimulation in AR and VR. So this one had multiple layers. So you see the hardware. I just put up some example from the brush things as a good example. So, but this one is relatively, as I said before in the lectures, some my previous lectures, that the Wolforia, if you put in, I think run in the last couple of weeks of your AR sessions that are about using Wolforia for beyond image target. So you have a target that shaped differently, which it could be a cube, could be a box and things like that that allow you to be able to kind of print it out and be able to play with. And the technology is just work. So Wolforia is a build already built in with something of a robustness to be able to people to be able to occlude some of the pattern on the mark on the visual target, and then the tracking still work. In the older generation tracking like AR toolkit, you won't be able. So if you cover part of the marker pattern, which is a square pattern on the object, then completely computer vision will completely lost the tracking. So Vuforia already go past that part. Okay, but not the Vuforia is still nowhere near what AR core will be able to do. But AR core come with the problem with that they don't define the real. You can't anchor into a real space easily, as opposed to be image target. But that's because you simply fix them. So I think a lot of them will become interesting there. But the tangible object here are emerged quite a lot. So a lot of this is you can see them play in IoT space, Internet of Things, ubiquitous computing, embedded computing systems. So I mean, if you have those kind of background interests, they sometimes fly over into art exhibition. As I said before, there was some projection based, which I'll talk about next. But this tangible is always sort of something that you can, if you aim target to people that don't want to understand too much, but want to be able to do and see the action reaction come back. I mean, this is one of the quite effective form of interaction. So spatial AR. So this one is base projection based. So this one is really just use AR camera, not AR camera, so using a camera and projector, okay, into a neutral form of the sensing, right, or of the surface, neutral material surface light. Okay. This allows you to kind of map the environments, map the reflect material contents, like in this case, models. Okay, allow you to project different things, the multiple cameras. So essentially, you create an augmented reality, but you're creating it from outside in, from the projector projected in. But the process is quite different. If this is to happen with a VR headset or mobile phone or camera, then it basically would just recognize this shape of space. Okay, so but to be able to tailor this kind of a high resolution projection display is going to be a very hard task for the AR, the current Vuforia. Okay, because essentially you had to put marker there, or even before AR core, you probably recognize what the structures are, but to paint the environment there on the surface, it's something else. So projective display is quite suitable for that type of thing. So that's why this museum and other exhibitions are more to this, rather than you will see this technology kind of go into the art exhibition when they're projected on a very, very tall, famous structure, but using the night light, using a nighttime project something into the wall, creating a new structure for special occasions. So those are really just taking out from some of this technology and do that. Okay. So last week we talked about these machine science of technology. So this one is really nothing much. I mean, it's just touch on different basic components that people are play with in this technology science, so you get you more idea. But of course, as these technologies are keep moving around quite a bit, it's important for you to kind of get a chance to look at them. Okay. All right. So that would be the end of my lecture for now. Let me